Hello everyone, we are Team Outliers and our team members are 李佳琦、林拓宇、张子浩、周全、密、刘耿华东. And now we are talking about the NLP chatbot for Cox website. And first, let me do a brief introduction of Cox. It is a research and development company in applied cognitive science. The website provides a platform for the public to see how their programs target cognition to enhance learning ability and as well as for individuals and organizations to partner with Cox. But the lack of retrieval function makes it difficult for visitors to filter rich information. So it is quite necessary for us to design such a chatbot for it. And next about algorithm, firstly, we use Scrappy in Python to scrap websites and extract structured data from pages. And the right side is the structure of Scrappy. We can say that there are like quite important parts of it, like engine, downloader, scheduler, item pipelines, and also the spiders. We choose the crow spider, which is a derived class of spider, because it defines some rules to provide a convenient mechanism to follow up links and obtain links. And next, we use TF-IDF algorithm to do the information retrieval and text meaning. Well, it is a combination of the term frequency and inverse document frequency, which means that the high word frequency in a particular file and the low file frequency in the entire file collection can provide a high weight TF-IDF. So it tends to filter out common words and return important words. And next, we also use cosine similarity to do the text similarity calculation. From the formula, we can say that the closer the cosine value is to 1, it indicates that the included angle is closer to 0. That is, the two vectors are more similar. And next part about the experiment will be presented by our team member, Jiaqi.
Thank you, Liu Genhua Dong. I'm Li Jiaqi. This part is about crawl data. As mentioned in the previous session, we use the Scrappy framework to crawl the entire site of Cox. The first step is to understand the architecture of the website. We open the home page of the website. This page includes some summary and introductions of its subsections. We need to store all the information from the home page. All text content is stored under this tag. We locate the text content through the XPath. In this way, we get the text content of homepage. However, we need more information from the subsections. We enter the tag of one of the items in the main menu, such as what's on. We can see its URL and the submenu URLs. After we download the entire URL structures of the website, we can enter each submenus in terms to get the required text data. The page structure of this submenu pages are similar. There are two examples. The first one is this website. The same as Cox homepage, the text data of this subpage is contained under this tag. Therefore, we can download the data of these pages in the same way as homepage. And the second example is this website. This page lists the speakers who will speak at Cox. This page, it doesn't have a tag like this one. However, we can get the text data of this page through the XPath. After understanding how this website is organized, it is easy to crawl data from it. Because the easy structure of Cox website, we only need to use Scrappy model of patterns to crawl text data from it. This part is the text data obtained by our crawler. Since our chatbot is closed-field robot based on searching and matching method, we need to process the text data and organize it into crops with the form of query and response pairs. This step is necessary because the chatbot based on this method have to find a more suitable response from the candidate response. Next part will be introduced by my partner Lin Tuoyu.
Okay, thank you, Jiaqi. And I'm Lin Tuoyu. I will introduce the mechanism of our chatbot in this part. As we can see in this picture, the chart is the structure of the chatbot, and now I will introduce this part by part. Let's begin from the user input question. First, read the string of the input question from user, and then we read the CSV file of the query database and combine it with the input question. Next, to this new query database, we run the clean text function on each of these queries to perform the text cleanup, including removing special symbols, URLs, and other irrelevant information. Then we perform the lemmatization to standardize all the words in every query into the corresponding word roots, which can reduce the feature dimension and improve the matching accuracy. Of course, we convert all the words to lower cases. Now we get into the text vectorization part. First, we need to remove stop words. A customized stop word list is used because the traditional stop word list will remove words such as when, who, where, which may express key information in chatbot. Then the TF-IDF algorithm is used to vectorize all the claimed corpus, which contains the input query. Then we use the vectors to calculate the cosine similarity. We calculate it between the original query set and the newly improved question. Next, we record the corresponding index of every cosine similarity value. Next, we select the index with the largest cosine similarity and retrieve the corresponding answer from our answer database. If the maximum cosine similarity is still below 0.5, then no answer will be returned. We also build a simple learning mechanism. If the newly improved question is successfully matched to any answer, it will be used to update the corresponding original question, so as to continuously improve the query recognition ability of the chatbot during use. So next part, my teammate Zhou Quan will introduce how to use this chatbot.
Okay, thank you, Tolly. And here is my next part. And the next part is chatbot display. I divide them into functions and examples. This chatbot basically matches the questions with the response if they have similar relationships. There is a database of responses stored in the chatbot. Every question accordingly matches a response. We set this path between question and response in advance. And when a person asks a question, if this question overlaps the question stored in the chatbot database greater than 50%, we match the answer accordingly to these stored questions. If the similarity less than 50%, it will generate a response. Sorry, I don't know. And the great part of the chatbot is that it covers almost all the information in the website. When a person asks questions in the website, the chatbot will probably respond to the correct answer. Then a person talks about the daily conversation, the chatbot will have an answer prepared before. And there is a various drawback that the chatbot is not smart enough. It is not flexible. We limit the range of the answer. The answer is simply limiting the information of the website about the job, achievement, education background, past experience, etc. Daily conversation is also like this. If we ask them very flexible question like a joke, it will generate problems. And next part is examples. The coding part is being introduced by Tuoyu and other teammates. Especially, I want to talk about the word to vector function. We only screenshot part of the stop words. In order to match the question and response, we have to convert the text into vectors so that we could use the cosine similarity to judge if the question is similar to the question stored in the bot and generate the response. And we delete those words, which is not important and might affect the matching process. So basically, we list the stop words manually, but maybe it still cannot include all the stop words situation, but it is probably enough. And here is the output of the chatbot response. The first output is mixture response of the daily conversation and the conversation related to cogx. This is the chatbot responses. When a person asks a question, he will generate a response. And second part, second and third picture is the inquiry about the information in Cox website. Here we transfer the next part into Zhang Zihao.
Thanks, Zhou Quan, and I'm Zhang Zihao. Now let's come to the conclusion. First, about the achievement. Basically, we have achieved the goals that we expected. That the chatbot can answer the user's questions, and which can simplify the steps of getting information about specific issues about Cox. But we still have some improvement to do. First, corporate pre-treatment. For now, we treat the corporate manually, which means that we preset the questions and the answers. But in the future, we expect that the chatbot can treat the corporate automatically. For example, for this sentence, the chatbot should extract the basic information like activity, time, and method, and it will only save the basic information into the database, but not the whole sentence, which will be convenient for the future steps. And second, memory. In some situations, the users may ask questions like, how much is the festival pass? And then the second question, what does it include? But not what does the festival pass include? In this situation, the chatbot would not be able to recognize the question directly. So we hope that in future, when the chatbot meets words like it, those, that, it may go back to the last question and get some keywords from that, and then the question will be recognized correctly. And third improvement about answer generating. For now, all answers are preset, so all answers are fixed. But we hope that in future, the chatbot should generate answers according to the information that asked in the question, and then it would provide only one or two sentences that contains the most important information that is needed by the user, but not several sentences. And then the similarity judgment. For now, we use the TF-IDF to judge the similarity, but TF-IDF ignores the sequence of the words and the meaning of the words. The situation about the symptoms is ignored. So in the future, we may try to use dual LSTM to improve the speed of the match and the accuracy of the match. So that's all of our project, and that's all of our chatbots. We are the outliers. Thank you.